Hey guys, welcome back to the channel. In this video, we will continue our journey to calculus with the idea behind functions, which I will be introducing in this video, and why they're important to us in mathematics and physical sciences. Now, before we hop into the meat of the video, please hit that red subscribe button and smash the like button for more content. So let's just get into it. All right. So before we could actually define a function in mathematics, first we need to define a relation, which is what we see here. And when you hear, so ignoring this pieces here for now, sorry about that. What comes to mind when you hear the word relation? So from the root of it, you guys might think how things are related to each other, a relationship between two things. So pretty much in mathematics, that's not wrong. But in mathematics, a relationship is a relation is relating two things together, mainly inputs and outputs, and so a relation, so input and output together, pretty much. So for every input, there is an output. So any input value, there's output value, and so let's let the input be x. Which we also define as the domain, which you guys need to remember that for later on in this chapter and the rest of mathematics. It's really important, trust me with that. And outputs. Why? And technically it is the codomain, but for simplicity we define it as the range. We don't really worry about that until later on higher up mathematics. Alright, so okay, you guys are probably thinking, okay, Swiss, I get that. But how does this relate in real life? Why do I need to know a relation before before we know a function? Sorry about that, guys. This is my fourth take today. So before we move on, we also define a relation as a set of ordered pairs. Okay, so, alright, let's move on. Alright, so let me grab another color. Alright, so, picture we have a vending machine. Or, picture we have any machine, like a television remotes, or even something as simple as a toaster that we sometimes use in our morning lives. Okay, so let's let this square be a toaster. I'm bad at drawing. Sorry about that, guys. So let's let this be a toaster. Okay. Okay, so we put different things in. Okay, so let's let this be toaster. Okay, so we put a piece of bread in. Okay. We put bread inside of it, and we get out what we call toast. And we put in waffles inside, and we get out toasted waffles. We could put a fork in. I don't recommend doing that. Trust me, that's not a good idea. And we get a fire. Alright, and so on and so forth. We could put anything into a toaster, and we could potentially get an output. For everything we do to anything we put into a toaster, what if we put into a microwave? Heck, even a vending machine. We get a desired output. So essentially, so let me turn the page. Let's get a new sheet of paper. So pretty much, every relation has input and output. So just given a bunch of ordered pairs. So we could draw a relation as a chart. Okay. So 1, 2, 3, 4. Okay. Let's do 1, 2, 3, and 4. Okay. So this is input value. So I let x be input. y be the output. All right, so what we get, so we put a 0 in, we get a different number. We get a number, we get 3. What if we, so what if we put a different value in? What if we put 1 or 1.1? We get a different value. So that's 4 or 5 and 6, 7, so on and so forth. Okay. So essentially, the point I'm trying to hit is whenever we have an inputs, we have outputs. All right, and so you guys are probably thinking, okay, he repeated himself. I'm trying to drive the point home with that because it's really important for this next definition. So you guys are probably thinking, okay, I get a relation. It has inputs. It has outputs. So for every input we put in, we get an output. Why does that matter to functions? All right. So let's look at the definition of a function. All right. All right. So function. Okay. So, and also every number. And every number doesn't have to be unique. We have different outputs for each number for a relation. All right, so when you hear of a function, what comes to mind? Maybe how something works, maybe how something behaves. Oh yeah, and that's not totally wrong, but in mathematics, it's pretty much so mathematics, a function is a relation. So it's a relation, but it's a special type. That has one unique input, output for every input. All right. So going back to our toaster. Actually, let's do something else. Vending machine. So let's this rectangle be a vending machine, okay? Okay, so vending machines work is you put a certain amount of money in, you hit a button, it gives you a soda, okay? And so you put your money in, and it pops out a Pepsi. Oops, sorry about that, guys. Let me move that over. Okay, so you put in a quarter. It gives you a Pepsi. You put in $1. It pulls out a Monster energy drink. You put in a penny. It gives you water. Okay, so you put in your money. So your money is an input, and depending on the button you push, it gives you different outputs. So a relation is pretty much saying. So with this example, actually, let's make a better example to drive the point home. 0, 0, 1, 1, 2, 2. Okay, so we get 3, 1, 6, 5, 2, 4. Doesn't really matter. The numbers don't really matter in this case. But what does matter though is you see we have multiple values for x here. And we get different values of y. So we input the same value, but we get two different outputs, and that's a relation. Whereas a function, all right. So that's so what this is saying is, okay, we could put in any number, and we get an output value of. So we put our money into the vending machine. We press the button, and we get a water or a Coke by pressing the same button. Or if we're looking at our TV remotes, if the volume up button were to change the channel plus turn out the volume, or if we put bread into the toaster example, going back to that, if we were to have bread in a toaster, or it'll give us toast and toasted waffles in a fire. All right, and so a function in mathematics, let's grab a new sheet of paper, sorry about that, guys. So a function in mathematics is saying, okay, so if every one unique inputs, so there's a unique output for every input. So there's one number is listed once, and there's a unique output. And when we we'll graphically show this with the vertical line test later on. But all right, so an example of this. All right, let's draw a t-shirt. Okay. What if we have, all right, so we have 0, 1, 2, 3, 4. Okay. And we have the earlier example, 3, 4, 5, 6, 7. All right, so for every x value, for every input, there is a unique output. So this is a function. All right, so first off, you want to look to see if there's a x repeated. If there is, it's most likely not a function. And also, we want to see, so also you guys want to make sure, yeah, so pretty much no x's could be repeated and give us different values. Now, what if I gave you another example? Sorry about that, guys. I'm all over the place today. Oop, I don't mean to draw a graph. Sorry about that. Grab my sheet. I'm going to draw a t-chart. X, Y. What if we were to have 1, 2, 3, and 4? And negative 2. We have 1, 4, 9, 16, and 4. Is this a relation? All right, so, and you guys got to be careful here. A lot of people are too quick to say no. So you guys are probably thinking not a function. And that's not true. That's wrong. It is a function. I'll tell you why. It is a function. All right, you're probably thinking, okay, there's two of the same y values. You guys are looking there, and you probably see there's two y values, and it's not a function. Well, so graphically, this would pass the vertical line test. If we were to plot the points and connect them, it would pass, and it would be a function. But also, you guys want to see, there isn't any x values that are the same. This 4 here is repeated, yes, but the x values are different. So that's the end of our material today. In the next video, we'll be covering graphing functions with points and writing rules for functions with a t-shirt. But so just a quick review. All right, so we defined a relation as a set of ordered pairs with the input and outputs. And from that, intuitively, we get functions. Functions are a unique set of input and outputs where there's one unique output for every single input, meaning no x could be repeated. So I'll see you guys next video, guys.